And if they're able to deliver on that bid, they're going to get 10% higher bonuses. But the bad news is, oh, by the way, we sold this bid, and you have to do it in the same amount of time. You have 20% fewer, or 20% less time to deliver it. And we actually sold this really nice and cheap, so we're going to have to figure out how to reduce $300,000 in personnel in investments in order to do that. So what is the plan? We try to improve the work output. A few elements of this is too many people are working in a siloed environment. They're working in environments where they have different applications that are managed by different teams. They have processes where one may produce some of the data, the other is consuming it, but they're not necessarily doing end-to-end processes. So they're going to figure out how to get the integrated workflows. They're going to try to improve the productivity of the end users by about 10%. They're going to try to overcome some of the wait times that they have with the data transfers of the large visualization jobs, and they're going to try to shift from first in, first out to really priority-based decisions, so that they're putting the investments on the projects that are going to meet these goals. Also, from reducing costs, they're going to figure out how they can share their GPUs better, how they can share the high memory systems better. And they're also going to, again, from a cost perspective, focus on using the optimization and get another 5 to 15% utilization out of their systems. So what is the pitch? Just the high-level response. And so here I'm envisioning this is a vendor pitching this. They come in and say, I think the idea is we need to get you with Moab HPC Suite Remote Visualization Edition. This is a solution that will help you get 2D as well as 3D applications optimized. It'll allow you to collaborate between teams. It helps you protect from a from an IP perspective, because you're not shipping the data to the person that you're collaborating with. You're allowing them to simply interact with the visual experience while still protecting the data, and it'll allow you to share your GPUs and other rich resources, and it'll cover Windows and Linux. So that was kind of the offering. Then the next thing is, okay, that's not enough detail. Help me understand a little bit more of what's under the covers. So looking at the stack of technology, you have to have a remote visualization solution that is at the top of that. As again, you don't want to ship the data. You want to simply ship the experience. You want to have the optimization that is underneath that. And then you want something that's going to cover both Linux and Windows. And then, because this customer also happens to be having some HP technologies, it's nice that it also connects up with RGS for that investments that they made there, as well as VNC and DCV. So, looking at what is the experience. Some of this experience is how do we take this, instead of just being at the layer that is the traditional desktop, it's also extending that to thin clients and to mobile, especially those that might be in oil and gas or other such areas where they have to be out in the remote field and don't walk around with a high-end desktop. You need this to be able to leverage even thin client technologies to be able to get there. The other element of this is also on the network optimization. Is you'll notice kind of this tool down here is able to monitor how much network is being consumed by this remote visualization experience. You have the ability to tune how much is being consumed by the individual on a per user basis. So instead of just having a global rule, you're able to say, I'm coming in from my home, I want to reduce the frames per second to a very low level, and I want to get the quality at a different level, while someone who might be on the wide area network, local area network, might want to have a very high quality and isn't concerned about network. And that personalized control on a per user basis can make a substantial difference in terms of how much network is required, because if you don't have this, you are sending a tremendous amount of data from one site to the other site. You have to invest higher in the network infrastructure. This helps you reduce your network infrastructure investments to be able to still have that quality experience. The other thing is, as you're trying to get that quality experience, you don't want it to just be a single application. You want this to be able to look at a workflow application, because in the end you want to do a result. Your result is, I want to get a new plane to market, I want to make these decisions in terms of life sciences decision, or perhaps it has to do with a manufacturing or oil and gas space, but it's typically I pre-process something else is going to consume it, I'm going to model it with that application, and this allows you to create something with one application, create the data that's output, and begin just with a click to be able to consume that by that next application. And this can be an integrated, on a per application basis. So one of the other things for this particular scenario is you might find some other solutions that are out here, but it's also important to know that a lot of application integrations have already taken place. So perhaps you have a preference for the ANSYS Workbench or Fluent. Well, some work has already been done with them, or perhaps you prefer the Altair Hypermesh technology, or maybe ANSA. Again, this is just a subset of the applications, just looking at manufacturing. Certainly there's a rich set in oil and gas, in life sciences, in some of the research, physics and other such areas. But again, this solution comes with multiple years worth of development work towards different applications that are most common amongst users. The other experience that many solutions don't have is that you can't share. And so you may produce something and they don't have a means to allow another user to be able to come in and see that image at the same time. So this is, especially if they're out in the oil and gas world, you may have all of this seismic data, you produce something visual, and you have a collaborative partner, you can't ship them that data, you can simply allow them to share into that session from another location and see, and not only see this data, but you can interact with this data simultaneously. So if they wanted to have just mouse control and keyboard control to shift and rotate it and look at it in a different sense, they can go ahead and do that. And again, that's what helps protect the IP while allowing the collaboration. It can be both inside of the corporation, or it can be organization to organization. Think supply chain collaboration. Is that if I'm a large manufacturer, I may have 300 different organizations that are saying, I've got the bolts, I've got the transmission, I've got the blades, I've got this part. This is a place to allow them to meet in the middle, be able to look at different models. Maybe you're seeing stress models, etc. But the collaboration is important. And also on the workload management, this is integrated in with workload management so that you're not just optimizing what's happening from an end user experience, you're optimizing what's happening in the back end computational work of this as well to get that 90 to 99% utilization. And because there's sharing involved, you don't want it to be free-for-all sharing, you want this to be controlled sharing. So I'm determining how many users there are per server, or how many users there are per GPU. What is the priority of different requests and the like. Another thing that is unique here is many are accustomed to doing just a one-to-one with the GPU. Certainly this has the capability, so instead of having one GPU per user, very expensive, them only using it 5 to 15% of the time, you're actually applying something so that you can have multiple users simultaneously sharing the same resource, and it gives you a lot more efficiencies. Roughly a 4-to-1 is common. Depending on your applications, you might even get it 6 or 8. But the many-to-one is very critical to get that cost savings in there. Windows has a 1-to-1 model, but it also has a many-to-one model. On the Windows side, you do have to leverage technologies that are on the virtualization layers. We are able to get the connection into the GPU to punch a hole through the virtualization layer, so you're not getting the slowness of that virtualization layer. It's just giving you some of the abstraction of the sessions and gives you the high performance. And again, that can be KVM, it can be other such virtualization technologies that support the GPUs that you're working with. So now I'm going to show something that's not the recommendation. This is what is commonly the answer that they might have received without the solution. They might have had someone come in and say, hey, well, for your 50 users, you should get 10 with NVIDIA Quadro, high amount of memory, $16,000 each, that's $162K, and I'm going to have the 40 users get a little cheaper NVIDIA system. It's going to be $7,000 each, that's $444,000, And by the way, that doesn't include all of the energy costs for all of those GPUs that are being used at each of the desktops, only part of the time. The added network cost to be able to get the data there, and it doesn't include backup and other such things, because you're shipping around data, you don't want it to be lost, you'd want to be able to have that. So it's much higher than that 444, but this is the bad scenario that most people are using. And not only does it have that from a cost implication, again, 5 to 15% utilization, no sharing, they're redundant systems with GPUs, excessive maintenance overhead, they have the loss because they're trying to ship all that visualization data around, they have wait times that they're dealing with, they have collaboration issues, they can't share as effectively, and there's more security risk because they have the data, not just the pixels that are getting shipped around. So now the smarter offering. What should they have done? They should have centralized all of that visualization into a visualization cluster alongside of the computational cluster, and here you're getting a 4-to-1 sharing efficiency, so you don't have near as much hardware that you're having to apply. You still have all the desktops, so we bought you just traditional desktops, that's all you need there, instead of high-end desktops. And here you've got, you know, dual NVIDIA Quattro, 96 gigabytes on that, and other such. And again, the total cost of the hardware is less, but that's not the big win. The big win is the personnel time savings of not having to move the data. And if you just take, let's just take those 50 users, $175,000 from a weighted cost, you know, maybe they're getting 120 in salary or 95 in salary, but the per head count cost is really closer to something like this when you weight it, times it by the 3 years, even at a 10% savings of their time, 1 hour here, 30 minutes there, that's $787,000 just for that 50 user scenario that is being saved in this scenario. That not only pays for all the costs of the hardware, but that actually nets you out a $500,000 savings just in terms of personnel value from that. And again, you're avoiding the data wait times, you're accelerating collaboration, and you're reducing the learning frames. So if you compare having to have an outbound push of $400,000 compared to saving $500,000, that's almost $1 million delta between making the right decision that is centralized and leveraging remote visualization versus using the traditional model of they want another server to hug. You got to get off of that server hugging model, give them the controls that allow them to have the dedicated access or the committed access, but then again, you get all these other benefits that are coming in from the sharing, collaboration, wait times, etc. So the comparison, the next thing that they're going to say is, great, I'm convinced I need to do remote visualization with a centralized viz cluster, but now I have to compare this against my other alternatives. Can anybody else do a technology like this? Well, the answer is yes, there are some technologies out there, but you'll notice that there's some core differences. If you look at the Moab Remote Visualization Edition, compare that to Citrix. Citrix is only going to give you Windows. It's not going to give you Linux, and it's not going to give you the session sharing. So you've kind of lost some of the point by doing that. If you go to Microsoft's Remote FX, yeah, now you got Windows, you don't have Linux. It's only 1.x on OpenGL. There's no sharing. Once again, the same limitation. If I'm jumping over to RGS, I've got some Linux coverage, but I can't share GPUs. I just lost all of my savings because I'm not sharing those GPUs, so that means I'd have to put in a whole bunch more cost just to put extra GPUs because I can't share them. And I'm also not getting the, so then the last one is VirtualGL. Well, that's the opposite side. That's now on the Linux side. It has some sharing, but then you don't get your Windows. How many of the applications are they using on the desktop are actually Windows? Well, about 70% are Windows. So the answer is you really need both, and if you want both Windows and Linux and the sharing, there's only one solution that's really crossing that barrier. But just in case you did have something that was pure Linux, let's look at actual performance items. So up here, this is looking at frames per second. This is looking at amount of network or bandwidth. So if you dialed things down to try to get a low frames per second versus network, you can have 5 times better frames per second for the same network, or 2.5 to 5 times lower network consumption for the same frames per second. So basically 2.5 to 5 times better performance than what you would get if you just chose an open VirtualGL class solution. So the choice for them, well, obviously it became very clear. They needed Windows and Linux. That was core because they have a kind of a 70-30 split of their applications. The cost savings, they needed the GPU sharing. They're definitely getting that. The network and bandwidth, they saw they got 2.5 to 5 times better performance with this solution. Ease of use, yeah, they had the integrated multi-application workflows. That improved ease of use. They've got a great tool that allows them to give the personalized experience if they're at home versus elsewhere. Lower total cost. They are able to achieve this. In fact, there was $1 million difference instead of just a $300,000 difference. Reduced risk. Now they've chosen a solution. They've got it from Adaptive Computing. It's based on a solution that's been out there for 5 to 6 years. It's not just a newbie solution, and it has many applications, many customers that it's already been integrated with, and they know that they're getting, in this particular case, they chose HP hardware. They've got someone that's already dedicated to the desktop visualization space, and so the combined experience of Adaptive and these products really gave them something that reduced their risk profile by doing it. So that was kind of the storyline that tries to take you through why you want to look from when you're looking at your visualization elements, and again, it can be 2D as well, not just 3D, but when you're trying to do that, you should look at how do I pull that away from the desktop, how do I move it into a centralized server model, and why will this particular technology give me a better performance on my network and give me better collaboration with those that I want to work with. So that's the presentation. I'm certainly open to any questions. And they're also got T-shirts over there. They'll probably do a scan badge and hand a T-shirt if you'd like that. But any questions? If not, thank you very much.